Hello everyone, this is Group 22 and today we are making a presentation on the topic alkylation. Now let's delve into this interesting topic. At the end of this topic, students must be able to 1. Define alkylation, 2. Draw and plan the reaction mechanism for the formation of alkylated compounds, and then master Friedel-Crafts alkylation. Now one may ask, what is alkylation? Alkylation is a chemical process by which an alkyl group is attached to an organic substrate molecule by addition or substitution. An alkyl group is basically an alkene molecule that is missing a hydrogen atom. These alkyl groups bond to a number of atoms like carbon, nitrogen, and oxygen. Alkylation is an important reaction for the production of fuels from petroleum, and it requires acid catalysts such as hydrogen fluoride or sulfuric acid. So what this basically says is that alkylation is a process by which an alkyl group, that is an alkene molecule that has lost one hydrogen atom, is attached to an organic substrate, in this case an aromatic ring, by the process of addition or substitution. And we have a few listed types of alkylation reactions. The first one, which is probably not the most popular, is called the Grignard reaction. And a fun fact is that this reaction was named after a French chemist called François Auguste Victor Grignard, who discovered this reaction in 1900 and was awarded a Nobel Prize in Chemistry in 1912 for this particular discovery. Okay, so what is the Grignard reaction? This is a chemical reaction between an alkyl or aryl magnesium halide and a carbonyl group compound, such as an aldehyde or a ketone. And this reaction creates a new carbon-carbon bond and forms an alcohol as the product. Okay, so let's move to the next one, which is the Wertz reaction. This Wertz reaction was also named after a gentleman named Charles Adolf Wertz, and it is a coupling reaction in which two alkyl halides are treated with sodium metal to form a higher alkane. As the name goes, coupling, which means two. So two alkyl halides are treated with sodium metals to form a higher alkane. And also, a fun fact is that the disadvantage of this reaction is that it is not an ideal method for preparing alkanes because it undergoes various side reactions which might lead to the yielding of less of the desired product. Also, let's move to the Friedel-Crafts reaction. And this reaction was developed by a gentleman named Charles Friedel and another gentleman named James Kraft in 1877. And it is the attaching or addition of substituents to an aromatic ring. The Friedel-Crafts alkylation reaction forms alkyl benzene from alkyl halides. Also, with the Suzuki cross-coupling reaction, it is a type of reaction in which a palladium catalyst is used to couple a boronic acid with an aryl or vinyl halide or trifluoride. This reaction also allows the formation of carbon-carbon bonds between two sp hybridized carbon atoms, which is useful in the synthesis of complex organic molecules. And these or this is a diagram of some of the products formed from the Grignard reaction. Also, this with the wet reaction, as I explained earlier, we can see in the second example that two um, we can see in the second example that two alkyl halides are being treated with the sodium metal to form an alkene, which in this case is ethane. Also, here is a diagram better explaining the Suzuki cross-coupling of amides and the acyl and aryl cross-coupling of amides. Also, also the Fiedel-Crafts reaction, as I explained earlier, is an organic coupling reaction involving an electrophilic aromatic substitution that is used for attachment of substituents to aromatic rings. And when people say the Fiedel-Crafts, oh, they are also known for acylation reaction, but in this case we are only talking about the alkylation reaction. And one thing to also note is that a Lewis acid catalyst such as an iron chloride or aluminum chloride is employed or used in order to form a carbocation by facilitating the removal of the halide. Now let us look at the reaction mechanism for a better understanding. The first step is that a Lewis acid catalyst undergoes reaction with alkyl or alkyl halide, resulting in the formation of an electrophilic carbocation. Also, the carbocation proceeds to attack the aromatic ring, forming a cyclohexadienyl cation as an intermediate, and the aromaticity of the arene is temporarily lost due to the breakage of the carbon-carbon double bond. And the last step is the deprotonation of the intermediate leads to the reformation of the carbon-carbon double bond, which was lost in the second step, restoring the aromaticity to the compound. And this proton goes on to form hydrochloric acid, regenerating the aluminum chloride catalyst. Now let's look at a diagram for a better understanding. And we can see that the chlorine attacks the aluminum chloride to form a carbocation or an electrophile. And in this case, the aromatic compound attacks this carbocation, and then in the end we can see that there is one hydrogen left. Now for the compound to regain its double bond, or that particular carbon to regain its double bond, then it must let go of the hydrogen, and this is made possible through the aluminum chloride compound. Now the chlorine in this compound abstracts the hydrogen to form hydrochloric acid, so that we can get back our aluminum chloride that we started with, and this forms the product that is an aromatic compound. And then there are some limitations of the Fiedel-Crafts alkylation reaction. Now, since the carbocation formed by aryl and vinyl halides are extremely unstable, they cannot be used in this reaction. Also, the presence of deactivating groups on the aromatic ring can lead to the deactivation of the catalyst due to the formation of complexes. Also, an excess of the aromatic compound must be used in these reactions in order to prevent polyalkylation. Thus, to prevent multiple alkylation from happening on the same compound. Multiple aromatic compounds must be used in this reaction. Also, one thing to note is that this reaction is prone to carbocation rearrangements, as is the case with any reaction involving carbocations. Now, what this means is that you see the positive charge we had in the diagram, it is free to move around in the compound, and this happens in almost every reaction that contains carbocations. Thank you.